one, but this course is going to be taught, the practical is going to be taught using Python. And I have 10 days, a 10 days Python programming training on YouTube. And I've posted the link to the in the group chat. I've posted the link in the group chat. So some of you may want to look at it from that side. I'm not going to be the only person to take the course, so I'm going to take from the theoretical aspect of this. And if I have the opportunity, I'm also going to demonstrate some things. Demonstrate some things. But it is good that if you can, you watch the videos online. Those videos will not suffice for your practicals. Okay, it's going to expose you to the practical application of this. So if you are watching those videos, you will notice that as I was also teaching, I was also demonstrating practically in a development environment. So it is necessary that you watch the videos. Okay, so that is it for the video. Then some other persons that may take you, I don't know how and what they are going to teach you. And then why it is important again to watch those videos, or even the video you would want to watch. It must not be my videos. It must not be my videos. But those videos were actually a training session with students too. So it must not be my videos. You can go online and watch other videos. All right. Then why it is necessary is that when they fix practical for you in the lab, it may be difficult for all of you to really sit down and take the practicals and so on and so forth. But the practicals are also important. You must register for the courses, have the practical, go and answer present. But because of the availability of resources, you may discover that you will not be able to, or rather, you may not be able to grasp all the practical aspects of the course by just attending a few hours of session in the lab. So I kind of encourage you to look at it. Okay, before we proceed now, somebody is raising his hands up. Ifeanyi Emmanuel. So what do you want to say, please?
No, sir, I
If
was not seeing it. I'm seeing it. I was not seeing the screen. I was seeing it now.
okay, you can bring down your hand because I'm looking at reactions. So you can bring down your hand so that I will know that there's nothing. Can let me lower your hand down. Right. Okay, so first, we come to definition. We are looking at computer programming, so we are starting with definition. We said that computer programming is a process, okay? Is the process of designing. So you see some keywords that are in the definition highlighted in red, okay? So it's the process of designing. There is a designing first, then writing, testing, and maintaining instructions that computer can execute in order to perform a task. All right. Please, I'm hearing some voices in the background. Please mute yourself. So these instructions that we are talking about are written using computer programming language or programming language as the case may be. So the programming language actually is an interface, a kind of a communication interface where the programmer uses in order to interact with the machine, that's the computer itself. Okay, you want to communicate with the computer. We are speaking maybe English, Igbo, Efik, and so on and so forth. The computer does not understand that language. Now, in between the human being and the computer is a wide gulf. Okay, the computer only understands digits, and the digital units that computer understands are just zeros and ones. Now, how will a computer understand what you have written in a programming language. So that brings us to the issue of a go-between, and that go-between is in between the human being and the computer itself is a go-between that I can call a compiler or an interpreter. Now, when we talk about compilers, we are talking about languages that are compiled. And then when we talk about interpreters, we talk about languages that are interpreted. Now, I want to believe that you have done compilation and these two things, you have come across them in your course 101. So I'm not going to be delving deep into it. The point I'm making is that whatever the compiler does or whatever the interpreter does is actually to carry the things that you have written in a computer programming language like Python, like C++, like Java, and so on and so forth, and either to compile it into machine code, the machine understandable codes, or to interpret it in such a way that the machine is able to understand what you are saying. So the compiler takes on the programming language and then converts it in such a way that the machine will understand it. Okay. Now we have several aspects in computer programming. Number one is that you write the program, structure the code using programming languages based on a rule that is peculiar to a particular language. Now, when I talk about a rule peculiar to a particular language, what I mean is the syntax of that language. So what it means is that it is not the way some things are written in Java that those things are written in something like Python, C++, PHP, JavaScript, and so on and so forth. So the particular way that something is written, an instruction is given in a language, the rule that you follow in order to communicate based on a particular language is called a syntax. So syntaxes differ, or rather syntaxes differ with languages. All right. So if you are going to learn a programming language, number one is to have an understanding of what you want to program. Okay. The steps that you are going to take in order to program, to put down what you want. Okay. And those steps are what is known as algorithm. Okay. Now, if you understand the algorithm, how these things work, you now need to have an understanding of the syntaxes and semantics of a language in order to bring that algorithm into reality in such a way that it will be able to solve problems efficiently. So there are things, the aspects of computer programming is number one, the point where you are writing and structuring the code based on the syntaxes and semantics of that language. Number two, understanding the process, the step-by-step approach that you will take in order to solve a problem. Now, there is a key word that is here, and that is efficiently. All right. You can solve a problem, but the approach that you may be using to solve a problem may not be efficient. Okay. But yet you are able to solve that problem. Let me give us an example. Let's say you want to code a login system, and then you coded a login system, or rather, two persons coded a login system in order to log into an application. And then you would notice that the first person's program takes about uh, 10 seconds to run, and another person's program takes about 1 minute to run. If you are to choose between those programs, and one thing you notice is that the two programs were able to log you in into the application. So apart whether they are working is not the matter here. All right. Now, the matter here is how efficient is this? And the efficiency can be measured in terms of how fast the program runs. And then another thing that you may want to check is what is the space complexity. All right, that's what space does it take in memory. Okay, what does the CPU struggle to have that program executed? Does the CPU struggle to have the program executed, or does it execute it seamlessly? That's where algorithms efficiency comes into play. But this particular course now is not delving deep into algorithms. Now, the thing I'm trying to bring to us that number one, there is a writing and structuring of the program. Then number two, there is a designing of the algorithm so that that algorithm will be able to solve problems efficiently, not just solve the problems, but to solve those problems efficiently. Now, another aspect is that when you deliver your program, there are lots of things that may make it to malfunction, and then in the process, for you to be able to bring, or rather to look for errors in the program, that you are searching for an error that made this program to malfunction at a certain point in time, that process is actually called troubleshooting. And then you fixing that program, that error is actually called debugging. And then as the program continues to run, you may need to make some changes, updates. Sometimes you open your app and you get a message that is telling you that there are new updates to install. Okay, so when you have to maybe improve on that process, that aspect is called maintaining the application. And sometimes at the point of maintenance, you may want to make the application to work better. Okay, and that process is called optimizing the code. So you maintain and optimize code so that the app or whatever that you have programmed will perform better. All right. So those are the aspects that we need to be conversant with when we talk about programming. Now, before we go deeper and deeper, we talk about programming. Yes, but the matter is that when the moment we talk about programming, what comes to mind is how to handle your computer, how to begin to open maybe an application and you start writing program without having an understanding that life is all about programming. For instance, you wake up in the morning, you already know that I have lectures to attend. I have lectures by so and so time. I have meeting after lectures. I have this and that. And then the next thing now, if you are a good student, is for you to be able to maybe structure how you are going to attend to these things so that none of them will lack. So at the end of the day, you'll be able to beat your chest and say you did not waste your day. Okay, the process of doing that thing, trying to organize your life, putting things in perspective, putting things in order so that you'll be able to manage them effectively, that process is what is called uh, programming. And so, if you bring it to real life, you just discover that there are certain things that we need to put in place so that we will not be making a shipwreck of our lives, or that will not be actually wasting our resources. So, and there are things in life that we may need to automate so that we will not be coming back to them often and on. So when we look at these things, we ask ourselves, what is the role of programming in problem solving? When you look around, you already see problems. Now, the thing that you will need to begin to do is to think, what are we going to do to bring this problem to a conclusion, or rather to solve this problem in an environment? Say you want to attend lectures and you discover that you are having issue maybe with transportation from your lodge or from your hostel to the venue. That is number one. Now, you ask yourself, is there a way for us to develop a system that will solve this problem? When you begin to think about this, you are beginning to think in problem solving manner. Okay. Then another thing is that you may want to come to your class. For instance, like last year, when I came to your auditorium to have class, I discovered that lectures were clashing. Now, I don't know if you have looked at, maybe if you have witnessed lecture clashes, and supposedly that lecture was clashing with your set, because your set was, you guys were in 200, sorry, in 100 level when I came to take course 201, and perhaps you guys were there when the lecturer was handling CSE 201 with you guys, and the class was clashing. Okay, now you ask yourself, having class clashes, or whatever we can call it, is there a way that we are going to solve that problem? Okay, we are talking about problem solving. Okay, now we have a situation in photo when we don't understand maybe the pattern of students' behavior as it concerns the departments that students, maybe female students, are performing better than in other departments, something like that. It can become a problem, and you ask yourself, how are we going to find a pattern? You now discover that the number of students in photo are in thousands. How are we going to be able to fish out something to be able to make a conclusion that so and so things are happening? Now that brings us to the second thing that we see here. Now I'm already discussing what I have here. Okay, but let me start pointing to them one after the other. Number one, there's a routine you have, that when you wake up, this is what you do. This is what you do. Is there a way that you are going to automate that task? Is a question that you are going to ask yourself. If there's a way to automate this task, how? Now, when you ask yourself how, you are beginning to rail out step-by-step approach to automate that. So you are putting down an algorithm. When you are able to look at that algorithm and you discover that it works, then you can put that algorithm in a programming language using the syntaxes and semantics of that language. Okay. Another place you can solve a problem that I just mentioned now is when you want to look at a complex or a large data set, especially those that involve machine learning and so on and so forth. So you now need to uh, use programming to work on those data sets, because it's just one line of code. You are able to sort your maybe your data. One line of code, you're able to get the mean of the data. Another line of code, you are getting the variance in the standard deviation and so on and so forth. And then you can write a program to make predictions just based on the data you have at hand. That's where AI and machine learning comes in. So you need programming in order to solve that problem. For those of you that will want to major in so and so. And people in physics may be asking me where they have their, maybe where they have application here. You can develop maybe systems that will automate, especially when you are working in nuclear weapon, nuclear site, or some dangerous areas, and you would that's some dangerous areas that are difficult for human beings to work in. So you may need to program something like a robot in order to work in those areas. So you see that even in that environment, you need this thing, programming. All right. Then you talk about when you want to create application, talk about creating user-friendly applications and so on and so forth. You enhance efficiency and accuracy of system operations in fintech applications or in financial system, medical diagnosis. You use programming to improve communication and connectivity, as you can see in mobile application. As you can see in social media platform, messaging apps, and so on and so forth. So why is it important that you learn programming? Why is it important that you learn programming? Programming definitely keeps you ahead of your peers, okay? So you have career opportunities. Programming skills are highly sought after in industries such as software, cybersecurity, data science, medicine, and so on and so forth. So even in sciences, if you have good programming skill, you will stay ahead of your peers. All right. Another thing is it is important because learning programming will enhance your logical thinking ability, and you see yourself having analytical reasoning. You are asking yourself why things are the way they are. So you are not responding to things ordinarily. You are thinking, how do we solve this? When you begin to solve problems, you will see yourself kind of prophesying. Okay, what do I mean by prophesying? Because you will already create something that looks like a scenario that may come in future, and then you are already providing answers to such solution, to such problems. For instance, you will discover that there are some fiction films that you will see maybe 10 years ago, and the reality of what is seen in those fiction films are playing out. It is somebody that sat down to think about it, and then the question that film or movie tend to ask becomes a scientific question that people are making inquiries into, and then they are thinking on how to bring an answer to the supposed fiction, even at the point when the stuff came out. Let me just say one thing. For instance, you ask yourself, can humans fly on their own? And then this singular question can leave somebody to begin to think. You begin to think on how to make humans work. Are there facilities that a man can wear and is able to fly? If there are facilities, how are we going to make it to work? And then you begin to think, this can do this can do that, and so on and so forth. All right. Now, another thing is that when you learn programming, it helps you to automate tasks. And when tasks are automated, you notice that it will lead to efficiency, and it will save time. It will save human, maybe it will reduce exposure to hazardous environments, and so on and so forth. Okay, I've talked about creativity and innovation in passing when I was speaking about trying to invent things that seemingly that are not at the moment. Okay, now also coding is a universal language that is used worldwide. So you are able to learn a programming language, it will give you global relevance. What are the real world applications of programming? Where we can have programming take place in software development, in web application, in mobile application, artificial intelligence and machine learning. In these areas, in cyber security, in game development, embedded systems, and so on and so forth. These areas present real-world application of programming languages. All right. Now, when we write a program, there are things that are common, and I will call them essential components of programming. There are things that are common. Number one is that when we are programming, we are setting things in motion, right? We are setting things in motion. We are designing things. And if we are designing things to carry out things, okay, let me use the word, we design things to carry out things. So if we have this at the back of our mind, what happens is that those things we are talking about have two distinct characters, or whatever, how we are going to recognize them or place them in order to be able to work with them. Number one is that we will call them a variable. Okay, we call them a thing. And if we call them a variable, the essence is so that we can lay hold on them, we can lay hold on them and use them. So it is something that we can use. For instance, if we want to check what is the temperature of a person, so we call temperature a variable, okay, and we call that person another person a variable, okay. And if we are talking about a human being, we will now begin to discuss, or rather, we begin to uh, uh, make that human being, or rather describe that human being with the characteristics. And what are the characteristics? If he's a human being, he will have a name. One, if he's a human being, definitely we can make do with the height for that human being. If he's a human being, we can talk about the complexion of human being. So we give those things, those variables, okay, we give those attributes to that human being based on what we want to, or based on the focus of the program that we want to write. Okay, so it's not as if that we are going to describe every aspect of that human being, but we are going to describe them based on what we want to achieve in that program. What are the aspects? Okay, we can just talk about a person, and then if our program is just to compute maybe age, so we can now talk about age of a person. Now, if we have anything to do with gender in writing a program, then we can set a variable called gender, and so on and so forth. All right. So, and then if we are setting a variable, the next in is to define the type of the variable. Because if we are not able to define and establish a type for that variable, then we will not be able to effectively manage the variable. Now, remember, these things are called variables because they can change. Okay. Now, if we have to describe a person by his age, we know that if this program runs to maybe till the upper year, the age of that person declared is going to change. Okay. If it runs to maybe another 10 years, the more the years, the more the changing of the program. So that is why we call it variable. Now, if the way we want to handle the variable, if we understand the way we want to handle the variable, it will help us to assign the type of a variable. For instance, if we want to name that person, we want to call the person by a name, we know that uh, for us to be able to be conversant with that name of that person, we need to now define how that maybe how to write the name. So the point I'm making is that there are variables and there are data types that we can use. These are serious components. I'm just putting these things as essential to this essentials of computer programming. So there are different types of variables that we can have. Number one is integer. When we talk about variables that we want to represent and whole numbers, then we talk about floating point numbers, or double in some programming languages. And these are variables that do not that have decimal places. Now, it depends on the length of the decimal place, whether you have a double or float, and so on and so forth. Then you have variables that answers to yes or no. Okay. So, are you coming today? Yes. Are you coming today? Or let me just say, is today Monday? It can either be yes or no. So we call those kind of yes or no variables booleans. And then we have string, the ones that are that you can just write the name of a person, weekdays, and so on and so forth. Okay, so when we build a structure for variables, we can we can kind of manipulate these variables. And how we manipulate this variable is using what is known as operators. So when operator operates on a variable, we get a value, for instance. For instance, if we add 1 to the age of, we can add 1 to the age of a person, and we can multiply the age of a person, and we can divide the age of a person, and we can minus some certain numbers from the age of a person. So we can also compare the age of a person. For instance, you want to say if age is greater than 18, if age is less than 18, or if age is equal to 18, and so on and so forth. And then you want to say if not age, or if not this person. So you have some types of operators that are listed here. For example, you have the arithmetic operation that are used in performing mathematical computations. Then you have logical operations that are used to check logic. I don't know how to put it. We want to check whether this thing is true, is this or not. Then you have relational operators that you want to use it to check a certain variable against an established constant or whatever. Okay. Okay. Another essential component is how do we direct the flow of execution? Okay, how do we take control of the flow of execution? And this brings us to control structures. So the essential things that we have looked at in this area is variable and types. They're talking about the properties of whatever that we want to handle. Then operators for performing operations on those variables, and then control structures. So control structure direct the flow of execution in a program. So we have two basic. We have the loops, okay, loop structures that talks about the for loop, the while loop, the do while loop, the conditional statements, okay, and so on and so forth. So if you watch those videos, you will see all of these things and how it is demonstrated in Python. Right. Then going further, we have functions and procedures. Now, sometimes you may not need to repeat yourself. Okay. Okay. One of the ways, one of the rules in writing clean codes is do not repeat yourself. Now, if there are things that you perform every now and then, maybe there is an addition, maybe you are developing a fintech application or you're developing an application that you are going to use in your lab, and there is something that you want to do repeatedly. So instead of repeating the writing of that code often and on, you can put it in a function. So you have a function that performs an addition, you have a function that performs this and that, and so on and so forth. So instead of repeating yourself for every action you want to take, then you need to use a function. So you reuse it. So functions and procedures allows for code reusability and the modularity in programming. Okay. Procedures execute a set of instructions without returning a value, and then function executes same while uh, returning a value. All right. If you look at those videos, you are going to be seeing particles too. Okay, you have inputs and output operations. So some certain time or at certain times in your programming, you may need to put in something. Let me just say, for instance, you want to design a game, and that game will tell you what is the number in your mind. And when it's asking you what is the number in your mind, you now give the number. So it is requesting an input. Okay, so the output is the fact that you see something on your screen that is telling you, that is asking you what is happening in your mind or what's the number in your mind. Okay, and then you typing it in is you are supplying the information to the system. So we have input and output operations. So input operations are used in receiving user or external data. All right, you have a system of sending something into the system for it to be able to use it to do some work. All right, and then output is displaying results, storing information, and so on and so forth. Okay, now that we've looked at the essentials of essential components of a program, okay, we talk about high-level programming languages and low-level programming languages. Now, what are high-level programming languages? These are languages, okay, that are easier to understand and write. Okay, these languages are easier for you to write them. It's easier for you to understand them. When you are reading them, some of them are like as if you are reading English language, but with some little changes or little things that make them what they are as programming languages. Okay, example is Python, Java. These are high-level programming languages, and they require a compiler or interpreter to convert them into machine code. And basically, most of them are used for general purposes. Right. Now, when you talk about low-level programming languages, so when we talk about high level, they are closer to humans. Then when we talk about low level, they are closer to the machines. Okay. So when you talk about low level, you are talking like assembly language, machine language, and so on and so forth. There are kind of how do I put it? There are pros and cons of using them. So the pros of the high-level programming language is that it is easier for humans to understand and so on and so forth. But because it's easier for humans to understand, it is further from the machine. Okay, so before the machine will be able to understand it, it's going to pass a process of um, compilation and interpretation, or interpretation rather, and so on and so forth. Then so what it means is that there's going to be a time lag in execution when you are using a high level programming language. Okay. And then, but the advantage of low level language is that it is closer to the machine. In other words, it doesn't need much interpretation in order to work. It doesn't need much interpretation in order to work effectively. All right. So that means it's going to be faster and so on and so forth. Now, there are fundamental concepts in programming that you also need to know. I've said this in passing. I'm going to say it again now, looking at this particular slide. Okay, you have fundamental programming concept. Number one is syntax and then semantics. Syntax talks about the rule that define how the language is written, or how the program must be written in a particular language. That is syntax. So when you talk about syntax, it is not the way you write hello world. Maybe you want to output something in Python. It is not the same way you write it in Python that you write it in Java. And this is syntax. So if you write how you write something, maybe you use print statement to write something in Java. Although that thing is a good syntax, or rather correct syntax for Python programming, if you put it in Java, it's going to tell you syntax error, because Java does not understand the way Python understands. Okay, just like the way you say come in English is not the same way you say it in Igbo, it's not the same way you say it in Hausa, but all of them mean the same thing when interpreted uh, within the confines of the language that you are speaking at the moment. All right. Now, you talk about semantics. Semantics talks about the meaning of the written instruction as it concerns that language. So why the syntax is talking about the rule that you use to write the language, the semantics is talking about the meaning. All right. So there are some codes when you continue writing. Maybe when you look at the practical section, you will discover that a code can be syntactically correct but semantically wrong. And one thing I want to say that syntax errors violate programming rules, and so sometimes they are found. You discover them uh, during the compile time because the system will not compile it. Okay, the system will not compile it. So you discover them at that point in time. Then the other one, semantic error, may even run, but what it's going to do is that it's going to give you wrong outputs. And if you don't know, if you don't understand, you may not know where the problem is, because the program that you wrote is actually syntactically correct. So the language understood it, but it doesn't have any meaning. So it's not giving you anything. All right. So the next thing we're looking at is debugging, is the process of finding and fixing errors uh, in a program. I talked about it, troubleshooting, the process of looking for the error. Debugging, the same thing, finding and fixing errors in a program. Okay, you look at types of errors here. There are fundamental concepts, syntax errors that violate programming rules. You have runtime errors that you find during execution. For instance, you see division by zero, and then you find it during the execution of the program. You may not find it, it's not a syntax error, so it's not going to show. Then you have logical error, incorrect program logic that produces wrong results. So you're going to be very, very meticulous about some of these errors that may not show when you are actually writing the codes. Okay. Next, we have the history and evolution of programming languages. So although those ones are not much of what we're looking at, so look at early programming languages. I started with the evolution in 1940s to 1950s, talking about machine learning and the assembly language. And then between the 1950s and 60s, you talk about Fortran that was made for formula translation, scientific computing. Then you have COBOL that was designed for business applications. Then programming languages went further to evolve in the 70s, beginning with C, that formed the foundation of many other languages today. Okay. Then C got upgraded around the 1980s, where they began to think in objects. So you have object-oriented languages like C++, Java, and then in the early 90s or so, you begin to have Python and so on and so forth. So 1990s to 2000 present scripting languages for web development, JavaScript, PHP, data science, applications like R and Python, data science languages kind of, okay, like Python and R. Okay, so this is what we have for this first class. This is what we have for this first class. I don't know if you have any question. I would want to have you ask your question at this point in time. Okay. Any questions, please? Are we together?